Section 10.1, the counting principle and permutations. Let's jump right in. Permutations and counting have to do with probability and how many choices you have in a certain situation. So let's have this situation here. We've got a blood drive going on, and the workers at the blood drive want to have labels prepared ahead of time, and they know that they have 4 different blood types, A, B, AB, and O. They have 2 different RH factors, either positive or negative, and then there's 2 different genders, male and female. Now, they want to know, well, how many how many different labels do we need to have prepared before we have people starting to come? So we can draw a tree diagram here and set up our 4 different types of blood. And each of these types of blood could have the 2 different RH factor, and each of these types of blood with RH factor could have one of the 2 genders. So now this shows that we have either a male with A positive or a female with A positive, or a male with A negative or a female with A negative, or you get the picture. I don't have to write them all out, right? So what we can do is we can say, well, how many different labels do we need? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 different labels. So in this case, there were 16 different choices, different combinations, if you would, of these different choices. Now, this leads me to, this would be quite cumbersome to have to draw up these charts every time you wanted to count, well, how many different possibilities are there? That brings me to the fundamental, what do they call it? The fundamental counting principle. The fundamental counting principle simply says that you can multiply the different choices together. So in this case, the fundamental counting principle says that I've got 4 choices of blood types, I've got 2 choices of RH factors, and I've got 2 genders. So 4 times 2 times 2 equals 16, and that is much quicker than writing them all out and creating this table. All right, so let's say we've got a book sale going on. Let's use this fundamental counting principle. And let's say we've got a book sale going on, and the books that are on sale, we've got 5 different novels on sale, 3 nonfiction books, and 7 comics on sale. And I want one of each of those. How many different choices do I have? Well, once again, we've got 5 novels, so that's 5 choices, times the 3 nonfiction, times the 7 choices of comics. Plug that into your calculator. Take 5 times 3 is 15, times 7 should come up with 105. All right, not going to spend a lot of time on this because I think that's quick and easy. So the fundamental counting principle says to find out how many choices you have, take all of the different choices that are going to have to be matched up with all the different choices and then multiply them. Because you've got, for every one of these 5 novels, you've got 3 nonfiction. So 5 times 3, that's 15 different choices. Of all those 15 different combinations, you can put 7 different comics with each of those 15. So that's why we took them the 15 times 7. Fundamental counting principle. Okay, now what happens though if you start, let's start with this. So I've got a 4-digit customer code, and we simply use these 5 digits, 0, 1, 2, 3, and 4. Those are the only digits we use, but we're going to put those in combinations of 4 different numbers to make up my codes. So I want to know, well, how many different possibilities, how many different codes do I have? Well, in this case, if the number can be repeated, it's going to be different than if the number cannot be repeated. So let's think about if we've got 4 different codes, so we are 4 different numbers in this code. So 1, 2, 3, 4. So the first number can have the first place can have any one of these 5 digits. So that's 5 choices there. Then in this second place, if we can repeat those numbers, then we still have a choice of any of those 5 digits again. So we multiply that again by 5. And then our third digit can also be any of those 5. And our last digit can be any of those 5. So we simply use your calculator, take 5 times 5 times 5 times 5, or if you want to use 5 to the 4th power, either way is fine. And you should end up with 625. And I know that because I did it already. You check it and be sure. Now, what happens though if I say, well, I'm going to create these codes, but once you use a digit, you can't repeat that digit? What's that going to do to my number? So let's look again. We've got 4 digits, 1, 2, 3, 4. For the first digit, the first number that I choose, I've got a choice of 5 numbers. So that's going to stay the same. I've got a choice of 5 numbers. Now, when you get to the second digit, if you've already used one of those digits and you can't use it again, that leaves you only 4 choices left. Okay? So, whatever one if we used the 2, well, we used the 2. Now we only have these 4 choices left. So now let's say we used a 0. Now there's only 3 choices left. So we're going to multiply this total by 3 because there's only 3 options left. And then for my last digit, I would only have 2 digits left. So then you would take 5 times 4 times 3 times 2, and that would give you 120. Now, in this case, we're just talking about putting things and gathering things, and so we don't care about the order. Permutation is a word that has to do with ordering. If I want to know what are the permutations of A, B, C, or A, B, and C, what I mean is this. I've got the 3 letters A, B, and C. How many different ways can I order those letters? So let's see, we could say A, B, C. We could switch the B and C and say A, C, and B. We could make the B first and then have A and C. Or we could have the B first and say B, A. We could have the C first and say A, B. Or the C first and then B, A. So do you see how I found all of those combinations? Now, with 3, that's not so bad. But if you had 5 or 6 or 8 numbers, that's going to be a big deal. So let's look to see. We've got 1, 2, 3, 4, 5, 6 different choices, 6 different permutations here. This is going to be the same type of thing that we just did up here. If we can't repeat, that means that we've got the order matters. If we can't repeat what we've got. So when we choose an A, a B, and a C, the A, when we choose A, we've got 3 choices, either A, B, or C. Once we've chosen an A, B, or C, there's only 2 options left. Once we choose 2, there can be only 1 option at the end. So this 3 times 2 times 1 is going to be, that's where we get our 6, and that's the same type of thing we did here. Now, what we can do is, we know that's going to happen every time. If we can't repeat something, if we're eliminating it once we use it, then this is always going to happen. We're going to take 1 away and we're going to multiply by 1 smaller. We're going to take 1 away and multiply by 1 smaller. So mathematicians have come up with a way to do that, and lo and behold, they have put that into your calculator. This is called 3 times 2 times 1 would be 3 factorial. That's what this exclamation point is called, a factorial. Factorial. So write that down so you remember. 3 factorial means 3 times 2 times 1. So you can either multiply out in your calculator 3 times 2 times 1, or there is a little factorial button. It should have an X with an exclamation point, and that's the factorial. So what you would do is you would type in a 3 and then type in that factorial button. Now I say that that's true on your iPhone calculators. I'm not sure I'll have to check on the scientific calculators. I think it's the same order, but if it doesn't work right, then switch it and push the factorial button first and then your number. I think that in this case it's the same as with the other calculators. All right. So to practice it with the 3 and see if you get 6. Practice it with this 5 factorial. Now this is the same as 5 factorial because the last number would be 1. All right, so even though we didn't use that 1, so 5 factorial should also equal the 120. So play around with that on your calculator and make sure. Also, let's do a couple more. So if I've got a TV station and they've got 8 stories that they want to present tonight on their program, and so how many different ways can they present these stories? They want to know, well, which one is first, which one is going to give us the best ratings, which one first, which one second. How many different ways can they they order these stories? Well, it's the same type of thing as this numbering system. If they once they choose the story about the cat, then they can't choose that one again. And then they're going to choose the story about the iron dog race, and that's going to be number 2. And so now they have only 6 left, and vice versa. So they're going to keep going like that. So this is simply going to be, we could write all of that out, but now that you know, you can simply say, well, they've got 8 stories. The order matters because if you switch the iron dog and the cat story, that's 2 different orders. So that's 2 different permutation. So if the order matters, I'm simply going to say there are 8 factorial ways that these stories can be presented. Okay? So once you do that, you can, what I would do is use that factorial button. Find it. 8 factorial is going to equal, because this is a huge number, 40,320. So that's 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. All right? That's what the factorial means. Now, what happens if they've got 8 stories, they only have time for 3 stories? How many different combinations of just 3 stories are there? Well, in this case, there's just going to be 8 times 7 times 6 because we only have 3 slots available. All right? So 8 times 7 times 6 then would be the 336. So 8 times 7 times 6. Now, and that's where I got that. I just plugged it into my calculator. 8 times 7 times 6. And this is where I got this is the same type of thing. Excuse me. We start out with 8 stories to choose from, and we choose one to be first. Now we only have 7 stories left. We choose one, and now we have 6 stories to choose from. And once we get 3 stories chosen, that's all we're going to present. So that's where the 336 comes from. Now, of course, we have a mathematical formula to present this, and this is going to make your life easier because you don't have to write out and remember. And okay, so this top part is what I'm talking about. If you've got permutations, n take an r at a time is how you read this. So I've got n permutations take an r at a time. What this means is I've got 8 things, all right, and I want to know the permutations of 8 items, and I want to take 3 of them at a time. So using this example, let's just do it. So I want to know the permutations of 8 items taken 3 at a time. That would be this problem exactly right here. All right, so I've got 8 stories. I want to just present 3 of them. So let's use our formula and see if we come up with the same answer. So what that says is the n, that's how many we're starting out with, how many stories we're starting out with. So 8 factorial over n minus r. So here's the total minus how many we want to take, and I'm going to take that, the factorial of that. Now here, there are 2 different ways you can work this. You can either take 8 factorial, and that would be, what is it, 40,320, and then take 8 minus 3 is 5, and plug in 5 factorial, which is, did I write that down somewhere? 5 factorial is 120, and then plug that in and take 40,320 divided by 120, and you should end up with 336. Another way to do this, and this is just the way I like to do it, you can do it either way. Either way is fine. Let me show you how I do it. I do it this way. 8 factorial over 8 minus 3 is 5 factorial. That's the same as 8 times 7 times 6 times 5 factorial. You see where I got that? 8, 7, 6, 5 factorial. 5 factorial means 5, 4, 3, 2, 1. The reason I stopped there is because this 5 factorial is going to reduce with that 5 factorial. So all of those factors will cancel out, leaving you just 8 times 7 times 6, which we already worked out, and we found that it's 336. Either of these ways is totally legit, all right? It doesn't matter, whichever way you prefer. I prefer to keep the numbers smaller and just cancel some things out. For me, there's less likelihood of making an error. But if you prefer to just plug it into your calculator and get an answer, that's fine too. All right? So we will do, and when I work them out in the next few sections, as I work them out, I'll work them out this way. But I'll try to remember to remind you, if you want to just use the big numbers, that's fine too. All right, one last thing before I let you go, if you're looking for permutations, but you've got numbers or letters that are repeated, what happens then? So in like the word mall, if I want to take the letters in the word mall and I want to know how many different permutations I have. Well, if you look at that, if you do M-A-L-L and now you switch the L's, you're going to get the same thing, right? So you can't call that two different permutations. So there's a formula. If there are repeating digits or numbers or outcomes, then your formula is going to be the number of outcomes you have, factorial, divided by the number of repetitions. So in this case, n factorial is 1, 2, 3, there's 4. So we're going to have 4 factorial, because that's how many letters we've got that we're looking for the permutations. And we're going to divide by the number of repetitions. And here we've got 1, 2. So one letter is repeated twice, so we have 2 factorial. And I should have said number of repetitions, factorial. Sorry, put that in there. All right, so what this means is you've got 4 times 3 times 2 factorial, and 2 factorial and 2 factorial reduce, leaving you just 12, and you're done. Let's do one that's a little more difficult. Let's do Cincinnati. Okay, same type of thing. How many letters are involved? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 factorial divided by anything that's repeated. So let's look. We've got C's that are repeated. C is repeated twice, so we've got a 2 factorial that we're going to divide by. We've got I's that are repeated. I's are repeated 3 times. So what we're going to do is we're going to multiply in between anything. We have to divide by all of the repetitions. So if you're dividing and dividing and dividing, you're going to multiply together what you're dividing. Does that make sense? Okay. And now we'll also have n's, 1, 2, 3 n's. So times another 3 factorial. So in this case, we can either take 10 factorial and then divide by each of these. What I would do is, let's see, what would I do at this time? So 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 factorial. And in all honesty, with this one, I probably would just put it into your calculator. 10 factorial is what? 10 factorial is a big old number, 3,628,800. And then 2 factorial times 3 factorial times 3 factorial is 2 times 3 times 2 times 3 times 2 is 72. And then divide those numbers. Another way to do it is this. Multiply by 2, and this is times 3 times 2 times 3 factorial. So your 3 factorials reduce. And I would look for anything. 3 times 2 is 6. And 2 factors this out as 2. And then I would take 10 times 9 times 8 times 7 times 5 times 2. All right? And you could even do, so 5 times 2 is 10 times 10 is 100 times 9 is 900. 900 times 8 times 7. All right? So it just depends on how is it, do you like to deal with the numbers quicker and easier in your head, or would you rather use your calculator and work it out? Either way, you should end up with 50,400. Okay? Easy sneezy. Permutations and counting principle. All right, see you next time.